Today we're going to do PMO question number 18 to 25. So this is question number 18. Let's just draw a quick figure for this. So this is circle. This is our circle omega. Word PQ. And so A is the midpoint of our PQ. So let's combine here. Then these two are equal. Uh, yes. So these are also equal. And then the bisector of angle AQ. So angle PAQ. This will be the bisector. Okay, so this is our point. So this is x and this is s is equal. So this is equal. Okay. And then AQ is 5 centimeters. So A is also 5, and then AS is 25. So AS is 25. This is 25. First, notice that since A is the midpoint of our PQ, this implies AP is equal to AQ, which is just 5 centimeter. That is, triangle APQ is an isosceles triangle. Isosceles triangle. Then we know that the angular bisector of an isosceles triangle is the perpendicular bisector of its base. Bisector of its base. Okay. That is basically x is midpoint of PQ, midpoint of PQ. That is, which implies px is equal to pq. Let us p1. Also um triangle AXQ is right angle triangle. Right angle triangle. Okay. So now basically do um so this is that and that's that. So now we take this x. So like by power of point x, we have so like this ax times xs should equal to xp times xq. So basically ax times xs should equal to xq times xp. From equation I like this one, we basically get ax times xs is equal to xp whole square. Okay. Now let length of ax be some z, which implies xs is equal to, so xs is just like this portion, so this is just the whole portion minus ax. So just as minus ax with just 25 minus z. So now from this we get xp whole square is equal to z times 25 minus z. Also from right angled triangle, right angle triangle xq using the Pythagoras theorem in this. So like this is this. So in this, AQ is the hypotenuse. So we get AQ square is equal to, wait, um wait, XP. Okay. Instead, let's take let's do this. Since like AXQ is a right angle triangle, so is AXP. So triangle AXP and AXQ are right angle triangle. From right angle triangle AXP, we get AP square is equal to xp square plus xs square. Xp square plus okay, plus xs square. Xs square, or AP square is just So AP square is just 5 square. 5 square is equal to XP square is here. So Z 25 minus Z plus XA square will be so XA. So XA will be just wait plus so XP. Wait on XA. So XA we have let XA be where you go. Okay, so like the XA is just Z, so plus Z square or 25 is equal to 25Z minus Z square plus Z square. So this differences, which implies Z is equal to 25 by 25 is equal to 1. Therefore, XA is equal to Z, which is just 1 centimeter. So 1 centimeter. Okay. Um, mm, 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 mm. Okay, so question number 19. So, okay. So two distinct numbers, so we have a set 1, 2, 3, blah, 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 to 30. And like if we choose two numbers A and B, they're absolutely different, will be greater than or equal to 5. Okay. So now, so first let's calculate the total number of pairs AB. So total pairs is just we choose 2 from alright, we choose 2 from 30. So C 30 is 2, which is just 30 factorial times 2 factorial, 30 minus 2 factorial, which is just 29 is 28, no 29 times 30, 30 by 2, which is just 425. Now um notice that notice that that for some uh, fixed difference d, fixed difference d, difference d, like let's say we have, let's say like we take a and then the next should be a plus b, like the difference between them should be d. For some fixed difference d, total pairs is equal to 30 minus d. Okay, so how? Let's just take an example first. Like example, we want d to be 3 in the pair a comma b. Okay, so that means a can be anything from 1 to 27. Why not 28? Because if a is 28, then b should be 28 plus 3, which is just 31. But that is not in our initial set, because our initial set is still 30, as you can see. And for each a, there is exactly another b, because like for d is equal to 3, 1 corresponds to 4 for b, and then 2 corresponds to 5, 3 corresponds to 6, and so on. So total number of pairs for d is equal to 3 is just 30 minus 3, because we have 27 pairs. This 27. So it's like the total, each of these corresponds to 1, so total number of such pairs is just 27 or 30 minus t basically. So it is easy to see that this is the formula for total number of pairs, okay, with some fixed d. Right? So now, instead of looking at the good pairs, like pairs which is greater than or equal to 5 in difference, we look at the bad pairs. Bad pairs. Number of bad pairs is equal to, we take d from 1 to 4, 30 minus d basically. So total bad pairs, this is just 4 times 30 minus 1 plus 2 plus 3 plus 4. I think this will be pretty obvious, which is just 110. Therefore, P required is equal to total number of total minus number of bad by number of total, which will be just total is our 435 minus 110 by 435, which just gives 65 by 87. So this is 65 by 87. Okay. Now question number 20. Right. Right. So first I did dicks. First I die rolled 8 times. And 3 of them are even. what is probability of six of them are even. Okay, so like if you are in grade 12, I think you know a formula like PA of, given that B is equal to P intersection B by E B. So this just means probability of A given that B has occurred is equal to probability of A and B occurring give upon the probability of B. So like let's say this is the Venn diagram. This is A, this is B. Then A intersection B and then PD. Okay, so like this part is this part and then this whole part is this. But okay, so now let's just write this. So A is equal to event with greater than or equal to 6 even space, and B is equal to event with greater than or equal to 3 even phase. Like to see how this formula comes, you can just write conditional probability in YouTube. Like this is a pretty easy formula to see. So it'll take like 2-3 minutes to understand. Okay, so like let's define A and P to be this. Then PA given that B has occurred is equal to PA intersection B by PV. But notice that like for our event, like we have roll the dice, we have rolled the dice 8 times, right? 8 times. And event with greater than 3 is like our B. So this is our B. And then A is event with greater than 6. Like if a die is rolled 6 times even, then this already includes the 3 times even case. So the A is actually a subset of B. So like 3 times even. So this is 3 times even, and this is 6 times even. Because like 6 includes 3 times even case, but 3 times E does not like include 6. So like basically A is a subset of B, which is like easy to see. So if A is a subset of B, A intersection B is just A. So this just becomes PA upon PV. Okay. So now let's just calculate each of these probability individually. So now first total number of possible events, possible, okay, possible events is equal to 2 to the power 8, because every time there is either even or odd, so 2 to the power 8, which is just 2 to the power 8. Okay, so 2 to the power 8. Then first events were greater than 6 events. So this is just this is either 8C6 plus 8C7 plus 8C8. So this corresponds to 6 even, this corresponds to 7 even, and this corresponds to 8 even. So this is just 28 plus this is 8 plus 1. You can just expand and see. This is just 37. Therefore, EA is 37 over 2/8. And number 2, PV, for PV. First, events with less than 3 um events with less than 3 events is equal to 8C0 plus 8C1 plus 8C2. So this is just 37. Therefore, events with greater than or 3 events is equal to total minus this less than 3 one case, which is just 2 to the power 8 minus 37. Therefore, PV is to the power 8 minus 37 by 2 to the power 8. Therefore, required probability, required probability, required probability, i.e. PA given B is equal to PA by PV, which is just 37 to the power 2 upon 8 times 2 to the power 8 upon 2 to the power 8 minus 37. This cancels this, and this is just 37 upon 256 minus 37, which is just 37 by 219. So the answer is 37 by 219. Wait, 21. 21. Um, yeah. So like notice that all the numbers n is equal to n factorial times n plus 1 factorial times n plus 2 factorial. Like all of them are just consecutive factorials, which is just n factorial times n factorial n plus 1 times n factorial n plus 1 times n plus. Okay, so this is just n factorial whole square times n plus 1 whole square times n factorial times n plus 2. Now we know that like um let's say like like let's say a square times b square times c square is equal to some c, then this c is also a perfect square. Then for n to be a perfect square, like these are already square, so this needs to be a perfect square. So n factorial times n plus 2 needs to be a perfect square. Needs to be a perfect square. Okay. Mm, mm. Needs to be a perfect square. Now so n factorial times n plus 2. Okay, so for n is equal to 4, this is just 4 factorials times 4 plus 2, which is 24 times 6, which is 144, which is just 12 square. So n is equal to 4 volts. So this is the answer. Hmm, okay, so now this one. Okay. So our sequence is xn plus 1 is equal to cos inverse cos xn. Okay. And then x naught is equal to 180 by 29. Yeah. Okay, so basically here um xn plus 1 is equal to since like first like when getting first outputs are value between 0 to 180 degree, and then like by definition of cos inverse, if this part is greater than 180 degree, then this just gives 2 pi minus 2xn, which is just 360 minus 2xn. So our sequence is a piecewise sequence basically, which is 2xn for 0 less than x 2xn less than 180 degree, and 360 minus 2xn for 180 less than 2xn less than 360 degree, which is just xn is less than 90 degree, and here is 90 xn and 180. Okay, so this is the same thing. Okay. Now we have given cost inverse returns values in this, and then how many distinct value occurs in the sequence. So basically our xn is a like a repetitive function. So like after like xn, like after values, like let's say it's like 5 2 3 4 7 9, and then again it repeats like 2 3 4 7 9. So we need to count how many distinct values. Okay. So now like let's define a new function an such that xn is equal to 180 by 29 degree 8 times n. Now since x0 is equal to 180 by 29, we just have a0 is equal to 1, right? So now then an plus 1 is equal to n plus 1 is equal to 29 by 180 degree xn plus 1. We just like we're just swapping the places here, which is equal to 29 by 180 degree 2x of n, and then here 29 by 180, so 60 minus 2x of n. This is from 0 to xn 90, and this is from 90 to 180 xn. Okay. So this is basically using this. We're basically using this piecewise here. So now this is just so this is just now we just again use this formula here. So that is just 29 by 180 times 2 times 180 by 29 e of n, and then this is n plus 1, and this is 29 by 180 360 minus 2 times 180 by 29 e of n, and then similarly to get like the condition also here we substitute xn. we get 180 by 29 a of n, 90, and then 90, 180 by 29 a of n, and this will be 180. Yeah, yeah, better. And then so like this just cancels out, and then for here yeah, right. And then this is something like 2, so 1, this is just 1, um, this is half, this half, and which implies n plus 1 is equal to this is 2an. This is easy to see, like easy to simplify. It's just use 58 minus e of n. This is for an 0 to 14.5, because 29 by 2 is 14.5, and here 14.5 less than en, greater than n, and 29. Yeah. So now start with a0, and the sequence an is equal to, now we just compute, like we put a0 and then we just get a0. If we put a0 is equal, a0 is 1, then a1 is just 2 to a0, so that is just 2, and then a2 is equal to 2a1, which is just 2 into 2 is 4, and then we continue. And if you continue on, you get value 1, 2, 4, 8, 16, then 26, 6, 12, 24, 10, 20, 18, 22, 14, 28, and then 2. So like after this 2, the values just repeat. It just goes this way. Like it comes like 2, 4, 8, 16. So no new values are generated after this. So our required answer is this values. If you just count, this is just 15. So like an has 15 distinct values, and xn is just like a function of an. So this just implies xn also has 15 distinct values. So our answer is 15. 15. Yeah. 23. Yeah. Yes. So, 23. Okay. So let P is for penis, P is for number of penis. Sorry. P is just number of penis. N is number of nickels, and so on. Like D is just time, and Q is the square root of this. Then given P plus N plus B, D plus Q is equal to 100, is equal to 100. So this is equation 1. Um, also, also, we have $1 is equal to 4 quarters is equal to 10 times is equal to 20 10 is equal to 100 penny. Now we have given the total value is $17, which is just 1700 pennies. So now taking monetary values, and set penny is equal to 1 penny is equal to 1 unit, basically. Set 1 penny is equal to 1 right away. So is equal to penny. Then then penny plus 10 times plus 5n plus and a quarter is equal to $100, which is not $100, my bad. It's $17, which is just 1700 pennies. 1700 pennies. Okay. This is our equation 2. Also, so given is that we have given number of quarters is twice the number of times. So Q is equal to 2D, which implies from this equation P plus 10D plus 5N 5n plus 50 times is equal to 1700, or p plus 60 plus 5n is equal to 1700. So this is our equation 3. And recall equation 1, which is just p plus n plus b plus q is equal to 100. But we have q is equal to 2d, so this is just 2d, which implies this is just 3d. So we can write this as 3d plus n. And now we just try to we just we just multiply this by 5 and then subtract. So we get minus 4p. So this is 15, so this will be plus 45d, and this is just plus 5 and minus, and this is just 0, and this is 1200, 1200, or d is equal to 1200 plus 4p by 45. Okay. So now notice that d is equal to number of times, and because we cannot have like 0.75 number of quarters, 0.75 times, like we have one time, two times, but we cannot have like three half of times. That means this is just an integer, so this is integer. So 1200 plus 4p by 45 belongs to integer, which implies so this just implies 1200 should have, so that is, so now we just here we go. So how many pennies? So p belongs to 10, 12, 15, 20. Yeah. So these are our like options. So now we just plug each of the values. So when we plug uh, 10, we get d is equal to 120, 1, no, 1240 by 45. When we plug 12, we get 1248 by 45. When we plug 15, we get 1260 by 45. And when we plug 20, we get 1280 by 45. But this is just 50. This is what 1260 by 45. So this is 28. So this is 28. So this belongs to integer, but this do not belong to integer. This does not belong to integer. This does not. So this one is the right answer. So please got 15. To 15. Question number 24. So let's see. We have a rectangle with 10 and 6. So A, B, C, and D, 10 and 6. This is 10 and this is 6 basically. And then we have some point some point P on BC. So some point P on BC, and we connect AP. So we need AP, okay, and then DV. So it's DV, DD, and DC. These are just perpendicular, and DV plus DC plus ED is equal to will, and we need to find the triangle APD's area. Actually, so APD, so AP and D. So like this is just a true problem. True problem because this condition is just unnecessary. We don't need this condition because notice that APD is like lies on this rectangle, lies on this rectangle. So its height is basically just the length of this rectangle, which is just 10. So triangle APD is equal to half base is just AD times height, which is just half 6 times 10, which is just 30. So this is just 30. We don't need this condition at all. 25. See. Okay, so we have S is equal to K is equal to 148 to root under K plus B plus root K. Now let's try to rationalize the denominator. So we just multiply with its conjugate. K root k plus 2 minus root k. And like this is this. So this is k is equal to 1 to 48. 2 root k plus 2 minus root k. Pull up on this is just k plus 2 minus k. So k and k cancels and 2 and 2 cancels, which is just equal to k is equal to 148 root under k plus 2 minus k is equal to 1 to 48 root k. Now we just try to like we just shift this. We just get k is equal to 3 to 48 plus 2. So 48 plus 2 is just 50 root k. Because like these and these are equivalent. Because k starts from 1, but k plus 2, and here it just starts from 3, and then k minus k is equal to 148 root k. Like try to think about why this makes sense. It's like kind of obvious. And now notice that this is just k is equal to 1 to 48 and then 50. So like 1 to 50, and then so this part is just 3 to 50. So like 3 to 50, 3 to 50, and then we just minus from 1 to 48. 1 to 48. So this part just gets in. So we just end up with okay. So we just end up with this part. So this part is root under 49 plus root under 50 minus this part is just root under 1 minus root under 2. Others just get cancelled because it's obvious to see. Like, for example, if 3, then root 3, then minus root 3, and then, oh yeah, which is just after 49 is 70 plus this is just 2 root, wait, not 2, this is 5 root 2 minus 1 minus root 2, which is just 6 plus 4 root 2, I'm pretty sure. 6 plus 4, yeah, 6 plus 4, yeah, this is this. Okay, so that's all. And for anyone who's wanting the whole question paper, here it is. Okay.